9A, rational functions. Unit 9 is rational functions. 9A is find the equations of the vertical and horizontal asymptotes of functions. Recap of what an equation of a vertical and horizontal line, what they look like. Vertical line is x equals a number, and a horizontal line is y equals a number. Easy way to remember that is vertical, top of an x is v for vertical, and a y. If you flip it upside down, triangle matches up with an h for horizontal. Anyway, moving on. Things we need to know how to find vertical asymptote is the zeros of the denominator that are not also the zeros of the numerator. This may not make sense right now, but when we get into the problems, hopefully it starts making sense. Horizontal asymptotes, if y equals 0, if the numerator's degree, the highest exponent that is smaller than the denominator's degree. Anytime that happens, the horizontal asymptote is always at y equals 0. If the numerator and denominator have the exact same degree, then the horizontal asymptote is the numerator's coefficient. So coefficient divided by the denominator's coefficient. So we'll get into problems like that. And then if the numerator's degree is bigger than the denominator's degree, then there is no horizontal asymptote in the problem. So let's move on. Find the equations of the horizontal and vertical asymptotes of the function. So we have, first thing, always factor if possible. Factor every part of the rational function. The numerator here, x plus 2, cannot factor that. So we'll write that. The denominator, from practice from last class, we see that the lead coefficient of the denominator is 1. So you do 1 times what is 6, that'll add up to 5. Hopefully you're seeing 3 and 2. So you put 3 and 2, they're both positive. Way to get x squared with two binomials, x times x. So we have for vertical asymptotes, the zeros of the denominator. Let's see here, we have the 0, 4, x equals 2, the 0 is negative 2. 0, 4, x plus 3, the 0 for that is x equals negative 3. We have to look at the numerator also. The 0 for the numerator is x equals negative 2. The 2's here, these share in common. So when I look back at for a vertical asymptote, we have the zeros of the denominator that are also not zeros of the numerator. So negative 2 is the 0 of the denominator and numerator, so we do not count that as a vertical asymptote. But we do count x equals 3 equals negative 3. This is a vertical asymptote. Okay. We look at horizontal asymptotes. When you're looking at horizontal asymptotes, we look back at the original function. We look at what's the biggest degree of the numerator. Biggest degree of the numerator is 1. Biggest degree of the denominator is 2. So we have the numerator's degree is smaller than the denominator's, which is, we look back up here, the numerator's degree is smaller than the denominator's degree, and our horizontal asymptote is y equals 0. So the horizontal asymptote for this problem is at y equals 0. That's all you need for this problem. If you want to graph it, you can. There's no need to do it for this, for 9a. Moving on. And I have a graph on here, coordinate plane. We don't need to use it. So let's look at, for first factor the denominator. So if we factor the denominator, this is helping us look for the whole vertical asymptotes. So we have f of x equals the numerator, cannot factor. The denominator, we can factor out a 4. Greatest common factor is 4, leaving us with x minus 4. So the zeros of the denominator make the factor x minus 4. The 0 is 4. The numerator 0 is negative 3. There are no zeros that are shared in common here, so we just look at the denominator. The only denominator, the 0, is x equals 4. That is our vertical asymptote. So x equals 4. There is no other vertical or no other denominators that have zeros. So that's it. The horizontal asymptote. We're going to look at the original problem. So look back at the original problem over here. We have the numerator's highest degree is 1. The denominator's highest degree is 1. So when both degrees are the exact same, so those are the same degree. Look back at the notes from the beginning. And we have, so the second one, if the numerators and denominators degree have the same degree, or they're the same, it's the numerator's coefficient divided by the denominator's coefficient. So we're looking at this, the numerator's coefficient is 1, the denominator's coefficient is 4. So we have y equals 1/4 is where the horizontal asymptote is going to be. That is 9a. We'll move now on to 9b. So for 9b, we have to sketch a graph of the rational function labeling all relevant information. So relevant information are domain, discontinuities. Domain is x values, all the x values we've done earlier this year. Discontinuities is where will the graph, there will not be no x values in the graph. Poles, these are not horizontal or not vertical asymptotes. But are discontinuities. X-intercepts, we know about those. Those are just where the graph crosses the x-axis. So, moving on. Next graph, identify the points of discontinuity of holes, Alright, so first thing you should do still is to should factor. So next slide I will factor this. Okay, so now it's factored, numerator and the denominator. For discontinuities, abbreviated discontinuity is where x are zeros in the denominator. These are zeros in the denominator, so where x equals -3 or x plus 3, and x equals -4. Those are our points of discontinuity, so our denominators zeros. The holes. Holes are the zeros of the numerator and denominator that cancel out. So these cancel out, so our hole is at -3. And our domain. Our domain is where going to have it all real numbers. The little e means all real numbers. X cannot equal -3 and -4. I'm not even going to worry about graphing it right now. Another example, we have, let's factor it. I factored the numerator and denominator, take the greatest common factor out of each. The zeros that make the denominator 0 are x equals 0 and x equals -2. These are our points of discontinuity. They're x equals 0 and -2. Looking at the wholes, is there something in the numerator and the denominator that will cancel out? And there sure is. We have our x, those factors, so our whole is at x equals 0. Then our x-intercept, don't worry about those. I'll do domain next. Domain is always all real numbers, and then just list your, the x cannot equal your denominator zeros. 0, -2. Come to class with any questions. I will have one of these as one of the examples will be your quiz coming into class. Thank you. Have a good weekend.